Hey everybody, I'm Chili. Welcome back to Hardware 3D. Today we're going to take a little detour from the model loading stuff and we're going to work on our camera. Specifically, I want to get a nice first-person free mouse look camera movement system going because our current, orbital camera, it ain't going to cut the mustard when we start loading some more interesting scenes. Now to get our free mouse look camera, there's a bunch of pieces of the puzzle we got to put together. Number one is some WinAPI stuff where we got to be able to hide the cursor and to confine the cursor to within our window. Number two is we want to get access to the actual raw mouse input so that we can know how the mouse is moving independent of the cursor. And number three is we actually got to implement the transforms and the controls in our camera component to get all this stuff working. So in this video, we are going to take care of the cursor part of the equation. Let's get started. So let's take a look at the commits here. We've got them right now. The first thing we do is we want to disable the cursor, the mouse pointer on the screen, because obviously you don't want that thing flying around in a first-person shooter type situation. So looking at the commits, not that complicated. We've added a couple of functions here. In the public interface, we've added enable cursor and disable. And in the private interface, we've added hide cursor and show cursor. And we've also added this little flag here to tell whether the cursor is currently enabled. So how that works is, well, the hide cursor and show cursor uses the Windows API function show cursor. Now the way the Windows API works with this one is it keeps an internal counter. So when you call show cursor with false, it decrements that counter. And when you call show cursor with true, it increments that counter. And when the counter is above 0, that means the window will be visible, or the cursor will be visible. And when the counter is below 0 or equal to 0, the cursor will become hidden. That's how it works. So what we're doing here is we're doing a while loop because we want to keep calling show cursor with false until it gets down to 0. And the same situation with show cursor of true. But anyways, so that's just a little function there that does the actual Windows API stuff. And then in the public interface, we set an internal flag and then we call show cursor or hide cursor. So we're going to manage that state inside of our class, not hooked into Windows. Because as you can see here, it's kind of annoying. And if we do that, you can see here's the window and here's my mouse cursor. But when I move it down here, it disappears. No cursor is gone. Ooh, spooky. But you can see here, the actual cursor, it's hidden, but it's still operating. It's still interacting with ImGUI. It's just you can't see it. So that leads us to the next commit here, where we want to disable ImGUI, specifically when we're disabling the mouse cursor. It doesn't make sense to have ImGUI mouse input active when your cursor itself has been disabled. So in Windows.h, we add functions enable ImGUI mouse and disable ImGUI mouse. And in here, what are we doing? So you get IO to get that IO structure, and you can set the config flags. And so when we want to enable the mouse, we clear the bit that is no mouse. And when we want to disable the mouse, we set that bit. That's all there is to it. It's pretty simple. And then we're going to call that function when we call disable cursor and enable cursor. Now we can see here, you got my cursor. If I move it down, drag it down over the ImGUI window, there is now no interaction whatsoever. So that is working as expected. Now the next piece of puzzle is the mouse trap. So sure, we've hidden the mouse. It's not on the window anymore. It's not interacting with anything. But the cursor is still moving around. And if you're doing a first-person shooter and you're moving your mouse around, chances are the mouse cursor is going to go outside of the window. And then if you were to say click down, you might activate another window, put your game window to the background. Users are no longer receiving input. There's big problems happening there. So to come in here, mouse trap, we've added a couple functions here: free cursor, confined cursor, and free cursor. And those are added to the private interface. And I've also added a bunch of no except specifiers, not a big deal. Now the way that, let me see if I can find that guy here, confined cursor works, is you're going to call a function on the Windows API called clip cursor. And that allows you to confine the cursor to a rectangle in screen space. So the first thing we've got to do is we've got to get the client rectangle of our window. We get that rectangle, and then we map that from our window space into the screen space. And since a rect is just structure of 2 points. You can call the function map window points with 2, and it will map the 2 points of that rect in the corresponding window, map those points into screen space. And then you just call clip cursor with that, and your cursor is now basically trapped inside of your client rectangle region. And when you want to free the cursor, you just call clip cursor with a null pointer, and that removes the confinement. And then, of course, in enable and disable cursor, we're going to call confine and free cursor. And, well, let me show you how that will look. So we're going to have to do a little bit of modification. So in enable cursor and disable cursor here, we're gonna comment out the show and hide stuff so we can see the cursor, we can see what it's doing. All right, here you can see we got the window. The cursor is clipped to the window. I've set my task manager to be always on top. So you can see here, if I move my cursor over to the top right, it becomes visible when it's over top of another window. But you can see here, it is confined very definitely to the client region of my window. Even when it's over another window, it's still confined there. So that's a little interesting thing. Now that we know that our cursor confinement is working, what's the next step? So we look at the behavior here. The clipping works perfectly, but if you do something like Alt-Tab, go out here, and then click back on our window, we can see that now it is no longer confined. So it loses that clip state when you tab out to another program. And that's not a very good thing. We would like to, whenever we activate our window, and we're in, like, let's say first person free look mode, we want to re-enable that clip rectangle. So the first thing we're going to do here is we're going to try to handle it via the WM activate message. And what we're going to do is, if the cursor is not enabled, then we might want to confine the cursor. So the idea here is that, well, I think basically I had a misunderstanding. Maybe I read some bad information or just misread something, but I had assumed that wparam here, it has a flag active. And if that flag is set, that means that this message indicates that the Windows was activated. And if it is not set, that means that this is actually the window being deactivated. And so I want to free the cursor or confine the cursor depending on that. But now looking at the actual documentation again, right now as I'm recording, WA active and WA click active are both for when the window was activated. So WA click active is if it was activated by user clicking on it, and WA active is if it was activated by some other method. And otherwise, it is going to be inactive. So the second part of this if statement is fine, but the first part there should be a logical or in between here, and it should be wparam and active or wparam and click active. So that's one issue, but let's take a look and see how that works. So here I've started the program, and I'll tabbed away, and you can see we get the WM activate message, and it has freed the mouse, has removed the clip cursor. Now if I click back onto it, now we got another message. I can't see it right now, but it did not confine the window. We can notice that right now. Let me try to move the window over here. Yeah, it was another free. So clicking on the title here, what if I click away? Yeah, we get another WM activate, and that is the free. Let's click over here, activate and free. So clicking on the title doesn't do anything. What if I click on the application itself? And didn't do anything if I click on the client region. Now, what if I Alt-Tab to the application? I believe I am confined. So let me Alt-Tab away and look here, and yeah, it was confined. So it basically matches what I've just realized when recording this, in that you have to also check for the click parameter, the click flag. But I wasn't aware of that when I developed this. So how did I handle it? Let's look at that for right now. So what I ended up doing was basically down here in the WM L button down handler, I do the cursor check, enabled cursor check, and if it's not enabled, then when you click with the left button down in the client region, we want to confine the cursor and hide the cursor down here. So that's the way I ended up handling it. And also, up here in the WM activate, I do hide cursor and show cursor in addition to confine and free. And that, I believe, seemed to fix the problem. Yeah, so we're confined here. If I tab away and Now you can see the mouse cursor when our window isn't in the foreground, when it's not activated, we don't lose the mouse cursor when we mouse over it, which is nice. You don't want your mouse cursor generally to disappear when you're actually using it as a cursor. So like this, and if we click on the window now, it is going to reconfine it. All right, now in the interest of science, let's take our code there with the logging, and instead of doing the stuff we did here with confine cursor and hide cursor in the L button down handler, let's check that second flag on the W param of WM activate. So now if we have click active, we're going to confine cursor, and I believe down here also hide cursor. And this one's a little weird. Let me show you what I mean. So here we've got our window here. If I alt tab away, got my cursor. Now if I click on the title menu, you can see that it's called the confine. So it's done the clip cursor, but the cursor isn't being clipped. If I click away, it calls free. If I click on the title again, it calls confine, but it's not being able to confine it. Now what's interesting here is that if I click on the actual client region, it calls confine and it works. You don't see it here, but if I scroll down, you can see here it called confine, and then when I alt tabbed away, it called free again. So it works only if I click on the client region. Well, I shouldn't say only, because if I alt tab to my program, it also works. It is also confined. But if I click on the title bar, see if I can show you here, then it does not become confined. I don't know why that is. That it should now work. It's getting the messages in the right place. It's definitely calling confine cursor, and yet it is not able to do it. Can't do it. So what I've decided here right now is that we're not going to check this WA click active flag. Get rid of that. We're going to use the system that I developed here originally, which is handling it in the L button down. So it'll only do it when you're clicking on the client region, which is good, because when you're clicking the title, you might just want to do that to move the window around. You might not want to activate it. So that'll give you the user, it'll give them a nice way of distinguishing between, actions that will recapture and reconfine the cursor and actions that are just, messing around with the title or whatever. And in this commit here, I just remove that output string logging stuff. And there you go. We're done with the hiding and the capturing and the trapping of the mouse. But that's going to about do it for today. Stay tuned for the next video. We're going to look at how we can actually communicate directly with the mouse device using the WinAPI, get that raw mouse input. That's going to give us those relative motions that we need for our free look control. Until then, thanks for watching. Hope you enjoyed this video. If you did, please click the like button, helps a lot. And I will see you soon with some more Hardware 3D.